Hello everyone, happy Friday. We are going to be using trig ratios of any point on the unit circle. Now the reason why this is very important is because we're talking about any point on the unit circle. Okay? Now the reason why that's important is because the point on the unit circle, we have here unit circle, okay? The radius is always going to be equal to what? 1. 1 unit. 1. Okay? Now I know you guys are used to the 2 pi over 3s, the 7 pi over 6s, all of that stuff, right? But on the unit circle, there's an infinitely many amount of points here. The only ones we worry about are the ones like pi over 6, pi over 4, pi over 3. That's what we've been drilling into your heads, right? But a unit circle, there's infinitely many amount of points all around here. There's even a point here, a point here, a point here, a point here, all the way around. Okay, there's points in between. So what we have to do is we have to understand that we can still find the x and y value of this, and we can still find the sine and cosine, the tangent, the cotangent, secant, and all of that of these strands as well, you know? These strands here, these strands here. We can still find those sines, cosines, the 6 trig ratios of these points. Okay, so let's just jump right into it, right into an example. Okay, now because we know that this is on the unit circle, on the point P5 on the unit circle. Okay, so we know this on the unit circle, so we're going to highlight unit circle, radius is equal to 1. Okay, now we're going to see, okay, this is on the unit circle, and this is x is positive, y is positive. That means we're going to be in the first quadrant, of course. Positive, first quadrant, like you all know. Okay, so what we're going to do is let's try and draw it. Let's see how it looks like if we draw it. There's our coordinate plane. We have a unit circle, and radical 15 over 5. And radical 10 over 5, that's a point somewhere. It's something we don't know, but it's somewhere, I don't know, maybe around here, as long as it's in the first quadrant. Okay, this point right here is point P. Radical 15 over 5, and radical 10 over 5. Okay, our given says that it's on the unit circle, and it is on the unit circle, so we're going to put that there. Then we're going to use our reference angles, just like how we used it everywhere else. We're going to draw our reference angle straight down to make a triangle, a right triangle. Okay, so now our x value is radical 15 over 5, and our y value is radical 10 over 5. Okay, and also our radius, because it's on the unit circle, our radius of this triangle is equal to 1. Therefore, we already know what our sine is. Sorry, we'll make this theta. Our sine of theta is equal to radical 10 over 5. Our cosine theta is equal to our x value, radical 15 over 5. And our tangent theta is equal to, of course, y over x, which is equal to radical 10 over 5 divided by radical 15 over 5. Okay? So we're going to take this. Now you know that this looks a little bit funky. So we have to take this, multiply by the reciprocal. This becomes radical 10 divided by 5 times 5 divided by radical 15. Okay, we take the denominator here, we multiply it by the reciprocal, so we take it, multiply the top by the reciprocal, so we flip it. That means radical 10 over 5 times 5 over radical 15. Now we can cancel out these 5's, and we have radical 10 over radical 15. Okay, any questions so far? Good. So, what we can do here is we can rationalize radical 15 times radical 15. This becomes radical 150 over 15. 6 and 25. Yeah, you can break that down, that becomes 5 and 5. So we got 5 radical 6. So this becomes 5 radical 6 over 15. Cancel, cancel. Our tangent becomes radical 6 over 3. Okay, so we have our cosine, our sine, and our tangent. Alright, so now that we have our sine theta is equal to radical 10 over 5, cosine theta is radical 15 over 5, and our tangent theta is equal to radical 6 over 3, the rest is all cake. Alright, we can take this, we can find our cosecant theta by taking the reciprocal of whatever our sine theta was, which is 5 over radical 10. But we can't leave that radical on the bottom because that's a big no-no. Radical 10 times radical 10. Multiply that out, we got 5 radical 10 all over 10. We can cancel 5, 10. This becomes radical 10 over 2. Okay. Next is our cosine. We can change that to our secant theta, which is equal to 5 over radical 15. Rationalize again. Rationalize again. We got 5 radical 15 all over 15. Cancel, cancel. We got radical 15 over 3. There's our cosecant. And last but not least, we have our tangent. This becomes our cotangent. Cotangent theta, which is then equal to 3 over radical 6. The rationalizing, this becomes 3 radical 6 all over 6. Cancel, cancel. Then we got radical 6 over 2. There's our cotangent. Okay, so just because our points here is not 1/2 radical 3 over 2 or radical 2 over 2, it does not mean it's not on the unit circle. What that means is it's not on those terminal sides that we're normally used to. Okay? We have to also be careful for those negatives and positives of what quadrant we are in. Okay? Based off of what we have here, this is positive, everything else is going to be all positive. Okay, thank you.